So binary search, what happens? Okay, so there is, let's first understand the binary search, right? So linear search, so we have discussed linear search. So in linear search we understood that the time complexity is order of n, right? So if you are trying to search an element, so what you will do, you will keep on searching one element at a time, one element, one element, one element, and you will continue that process till last, right? So that's what the linear search we have discussed, right? So what does this particular binary search does? So this actually does not work on every data set. Okay, so this works only a specific data set. Okay, so which is known as the array. Okay, so there is a precondition. In order to apply this particular binary search, there is a precondition. So what is that precondition? The data, right? The data in the array, right? The data in the array, right, must be in sorted form. This is very, very important form point, right? Don't forget this one. The data in the array must be in sorted form, right? So what does this mean? So this means, so whatever the data we take in an array, we'll take an example and understand, but this particular binary search will be applicable only to that kind of data set, so which contain elements in sorted form. Let me talk, let me take an example. If I'll ask you, can I can I apply a binary search to this data set 10, 30, 20, 40, 50, 60, some element, right? Some element. Can I apply? Answer is, answer is no. If this is my ARR, I cannot apply binary search. Why? Because it is not satisfying the preconditions, right? So try to understand. The preconditions say the data in the array must be in sorted form, right? That means this data should contain sorted form. So which is why it is not sorted form? If you'll see, these two is violating the sorted form format, right? So if I swap them somehow, so I'll bring this 20 and to here and 30 to here, right? Now this is my array. Is it in sorted form 10, 20, 30, 40, 50, 60? Yes, this is now in sorted form, right? So if this is in sorted form, now can I apply the binary search? Answer is yes. After doing little modification, so you can apply the binary search into this particular array, right? So this is very important for us to remember. We can apply the binary search only to that particular array, so which is in sorted form. We cannot apply binary search into an unsorted format. Okay, so that's how it works. Okay, so let's first understand, then we'll go for the its corresponding algorithm, or else we'll go for the program, as well as we'll go for the time complexity, okay, and all. Okay, so how it works, right? So it does not work like linear search. There is a difference, right? How it works, and this works very smartly, right? So that's why we'll see the time complexity is going to be very less compared to the time complexity of the linear search. Okay, so try to understand. So what happens? Suppose I'll ask you, so how it works, right? So it works on divide. You might have heard about the divide and conquer, but this particular algorithm works on division, right? So how it divide this array into two parts, right? So how it does, right? Let's try to understand. So what happens? So what happens? Okay, so there is a formula. Okay, so this is this is my ARR, and suppose this is my left, right? L is for left, or maybe left, and this is my right. Okay, so this is my right. Suppose I am searching for 60. Let's take that I am searching for, it is a searching, again it is a searching, right? Searching means again I am trying to find out a friend, right? But in this time your wherever party is happening, there is a special sequence is there, right? So so like age group, like the age group is between like or some tag, or with respect to your company name, or with respect to your organization name, some tagging, or this is like sorted form. Your array is in sorted form, right? So that's why suppose I'm asking sort 60. So whenever you are saying that sort 60, so what you will do, because obviously you can do it like linear search, you can search 60 60 60 60 60 60, yes, found. But this is going to take order of n. So I want a optimized way to do this. That's where the binary search came into picture. So what is the optimized way? So what it is saying, so there is a formula by using which, right? So you first find out the mid of the array. So mid is nothing but left plus right divided by 2 and this lower bound. Okay, so we'll understand why we are doing this, but anyway, so we will also understand. So what I'm doing initially, so what is my left? So let me, I'm searching 60. Suppose I'm searching 60. So this is, suppose I'm drawing a matrix for your understanding, right? Suppose what is your left? So left is your 0, and what is your right? Right is your 6, right? And what is your then? So this is left, this is right, and this is your mid. Okay, so if it is 0 plus 6 by 2, right? So 0 plus 6 by 2, so what will happen? So you will find it 3. So now your mid is 3. So mid is 3 means, so this is going to be 3, right? 3 means this index. Try to understand carefully. So you got a mid now, so which is 3. You are searching for 60. Now try to understand, do I need to search in this? Once I find mid, so I'll try to compare 60 with 40, right? 60, try to understand, this is very very important. So 60 into 40, right? So 60 I'm trying to compare with 40. So when I compare 60 with 40, then I say that 60 is greater than 40. So do you think I need to search, right? This is very very important. So do you think I need to search in this particular space? Do you think I anytime, by any time, since I got a 60, so which is greater than 50, sorry 40, do I need to search in this particular space at any time? I don't need to, because this array is already sorted form. The answer is no. Why? Because the array is already in sorted form and 60 is greater than 40. So, and all these elements I know, definitely I know. So since the precondition it is satisfying, this is in sorted form, right? So I know all the elements present in the left of this particular 40 are less than, right? So are less than 40, right? And all the elements are present in this array are greater than 40. So I am searching for 60, and 60 is obviously greater than 40. So definitely 60 is not present here. 60 is not present in this particular array, right? Just try to understand how efficiency is going to increase, right? So at any time, right? So now I'll talk in broader sense. Suppose there are 1 lakh, 1 lakh number of, or 1 million number of elements are there, right? So then what will happen? I can at any time, I'll go to the middle and compare, and immediately I can half of the million record I can discard, right? I don't need to search, because either this number, right, 60, it is greater than this or less than this. It could happen also it is exactly same, like I'm searching for 40, then I'll get a match. So then if you'll realize, there are 3 cases are coming into picture, right? Whatever the data you are passing, there are 3 cases you are going to get it, right? So what is that? One is case 1. What is case 1? Case 1, if you are getting a match immediately, suppose you are searching for 60, instead of 60 you are searching for 40, that could be possible, right? So whatever mid you find, you got a match, you can return it. So that is one case. So if case 1 is data equal to ARR of mid, right, equal to ARR of mid. Okay, so this is one case 1, right? What is the case 2? So case 2 is, you can say, right? So case 2 is either I will search in this case in this side, or I will search in this side, right? So data is less than, suppose let me, you can take anyone greater than or anything. Suppose data is less than ARR of mid. This is one more case. Case 3, data is greater than ARR of mid. So these are the three possibility. Once you compute this mid, there will be three possibility. Either you will get a match here, like 40 you are searching and you got a match, or you will find a less elements. So data will be lesser than, data will be lesser than this element. So that means you are searching suppose 20. In that case, you will go into this element, enter into this case. Or else you will search the data. Data means 60. So which is greater than 40. That means data is present in this particular thing. Okay. And just try to understand, right? So so what you will do, suppose in this case, right? So in this case, right? So just try to understand. Suppose I'm searching for 60. Now I got a mid here, right? Mid is 3, right? So now mid is here. Where I need to search, right? So now I'm searching for 60. Definitely it is not a match. So this array data is, they are not matching. I'm not searching for 40, rather I'm searching for 60. So what you will do, you will again search. You don't need to search with this, rather you will search with this index, right? This is your new array. Try to understand. So this is like your new array where 60 might present, 60 might not present. Suppose you are searching for 80, then that might not present also, but still if it is present, so definitely this is going to present here. Okay, so that's where you will change your left and right. Try to see. So if your data is greater than array of mid, then you don't need this part. You can happily discard, right? So you can happily discard this part. You don't need this part also. Middle also you don't need, because it is not a match. So then what I will do? Why I'll do? So then my next left will be, try to understand. Now my array is like this. New array is, I need to search only in this search space. So that's why my new array looks like this. Is not it? My new array is left is this was right. I am not changing right. Try to understand. I am not changing right. So I will only change. So if you will realize, I will, if this is the situation, this happened actually. So what I will change? So left equal to mid plus 1. So that's what I will change. We'll go to the code, we'll go to the algorithm, don't worry. Okay, but I'm just trying to explain you now. So left equal to mid plus 1, right? So that means your left is going to now point to this index. Try to understand this index specifically. Fourth, mid is 3, you got 3. Now your left will be like 4, because this does not get a match. If you could a match, then you could have returned, there is no worry. But if you does not get a match, then you will search with this index, which is 4th to 6th. So that is how it gone, right? 4th to 6th. Okay. Okay, so now this process will continue, right? So this process, so think about a situation. If you could have got 20, you are searching 20. I'll complete this one, but if you are searching 20, then instead of searching this one, it does not get a match, you should have changed your right to here. Left cannot, because your search space should have been decreased to here. So that's where your right should have been shifted to here, because this is going to be your new array. So if that could have been your situation, then your right could have been right equal to mid minus 1, right? So that's how it works. Okay, right equal to mid minus 1, because your right is here and you are searching suppose 20. I'm just giving an example for 20. You got a mid is against 3, and 3 is, this is 20 is less than 40. Definitely it exists somewhere here. That's where you will search from left, because you don't need this right, rather let's move it to here. This is mid minus 1. So that's why right equal to mid minus 1, right? This is my new array. Okay, so that's how it will work. Okay, so let's complete this with the 60. Maybe we'll go for all these things. Okay, so I search for 60. I'll come back. So I search for 60. So 60, I did not get a match. I found a mid like using this formula. 0 is my left, right? So now my right is 6. Now I got a mid 3. Now see, it will go to which case? So this is going to go to this case, right? So data is greater than array of mid. Third case, try to see. It will go to this case. Data is greater than array of mid. So data means 60. Data means 60. So ARR means this ARR. ARR of mid is 40. So this is data is greater than ARR of mid because this is 60. If you'll realize this is 60, this is 40. 60 is greater than 40. So that's why it will come to here. Now your new left will be how much? Mid plus 1. So this is will be how much? So this will be 4. Okay, so like we did also, right? We did left is coming to here. So now your new left is 4. How about the right? Right actually did not change anything, right? So right is still remaining in the same position. If you look into this, because now my new array looks is this array, right? Because I'm searching for 60 and 60 is greater than this. So now my new array is this. So left is just changing, right? There is no change. So right is as it is. So now I will calculate my mid, right? So which is like 4. Again I will calculate the mid. Again I will do the same thing, right? So now this is my new array. I'll do the same thing, right? So now this is my new array. You can say, right? This is treated as a new array, but still the array exists. But still I'm treating as my new array where left is like this, right is like this. And what is the left? Left is 4, and this is like 6. Then again I will calculate the mid. So which is 4 plus 6 by 2, which is equal to 10 by 2, which is 5. So mid I got it like 5. This is my mid, right? So this is 5. So once I got this mid 5, what I will do, again I will check what whether data is equal to 60. Yes, so data is matching. If it is matching, then return it, right? Just simply return it, right? So that's what I was searching, right? So that's what I was searching. But instead of that, let me do one more step, right? So suppose my data was 50, okay? Instead of 60, my data is 50. Okay, so let's see how it will work, right? So now my data is 50, okay? So what will happen? So just try to understand. So data was 60, then we got a match here, mid, then we'll return, right? We got a match. No need to divide once again. So suppose my data is 50. So what will happen? So when I find a mid, so mid is 5. Now my mid is 560, but I am searching for 50. 50, okay, 60 and 50 are not equal. So then 50 is less than 60. That means it will go to which case? Case number 2. So this is going to apply case 1, sorry, case 3, case 3, right? C3 means case 3. This is going to apply case 2, right? Case 2. So because, so data is 50 and 50 is less than 60 array of mid, right? So that's that is the less than. So if it is less than, so what I will do, my right, because I need to search only this space. I don't need this space, right? Because this is less than. So I cannot go beyond this, left this, because already I have discarded this. No need to think about this. I saw that, okay, something is less than this. So I need to move my right to here, right? My right is also going to mid minus 1, right? Mid right equal to mid minus 1. Mid is how much? 5. 5 minus 1 is 4. So now my left is 4, right is 4. So this is my 4, again 4. Okay. So just try to see 4, 4, right? So now if it is 4, 4, then what I will do? Again, I will apply the same formula. Again, I will calculate the like mid. So which is like 4 plus 4 by 2, which is equal to 4. Again, my mid is going to point to here as well. Try to understand, right? And I will see, again, I will check data of is equal to RM mid 50 equal to 50. Yes, 50 equal to 50. I got a match. Yes, I got a match. Then I got a match. So this is my mid 4 I got. But here case 1 will be applied, right? Because I got a match and you will return, right? You will return, right? You will return, right? So that's how it will go, right? So that's how it will go. Okay. So this is the principle of binary search, right? This is the principle. So I'll just quickly recap. So what we'll do, Simple, it is very simple. First of all, the precondition is what? Precondition is that the data should be in sorted form, right? So if the data should be in sorted form, then what I will do, I don't need to search one by one because that is linear search. It will take order of n time. So we'll see what is the time complexity of this one, we will see. But what we'll do, I will try to find out the middle position, right? So then I'll try to compare that middle position with the data, right? Once I compare, there will be three possibility. Either the data will be equal. If they are equal, then return it. That means you got that particular match. If that is not equal, either it will be less than, the data is less than the array middle element, or else it is greater than the array middle element. If it is less than, so that means suppose this is my array, this is the middle, and suppose it is less than, then I need to only consider this part, right? I don't need to consider the greater element because it is already in less than part. Okay, so that's why I will not change the left, right? So if it is data is less than somewhere present here, then I don't need to search this space. So then I will change my right, because mid is not matching, so I'll change my right to mid minus one, right to mid minus one. This will be my new array, right? And if it is greater than, like this case, right, it was greater than, so what will happen, I'll search in this array, right? So this will be left equal to mid plus one, so which is 4. Okay, so that's how it will work, right? So that's how it will work. Okay, so that's how it will work. Just 1 second. Yeah, that's how it will work. Okay, so let's try to write down the algorithm, right, with this particular understanding. Okay, so I think some issues, but anyway, so so what I was trying to say, so this is how it works, right? So let's try to see how we'll formulate the algorithm, right? So let me erase this part only. Let me write down the program, right? So how the program will look like I already told. So we can take any language to implement this, right? We can take any language to implement this, but let me do it in just some algorithmical format, right? So that will able to understand, right? So that you can implement in any language, right? So so let me write it because I need all these things anyway. So what you will take the input, right? So you are taking a array as the input. So what is the size of the array, right? And then the data, right? So if I write down the program, if I are writing a function, suppose int, right? So binary search, BS means binary search, right? You can give full name, that is no issue. Binary search, okay? So binary search, okay, binary search. Okay, so what it is taking the input is the ARR array, and then it is taking n is the size of the array. You can calculate also, that is not needed. Data, right? So data means which exactly the element you are trying to search, right? So then the main important thing is that left and right, right? So immediately whenever you are starting, right, so you are seeing that what is the left is the 0th index, right? So that's where you will put, right? Suppose like you can take any language, but anyway, so int left equal to 0, right? So similarly, what about the right? Right, right is n is how much? In this case, n is how much? N is 7, right? Because 7 number of elements are there, but right is pointing to 6, so that's why it is n minus 1. So int right equal to, so right equal to n minus 1, right? So this is very, very important, right? Left is 0. Now you are ready with this left, right? So what else you need to do? You need to calculate the mid value and again try to compare if it is data. Three cases actually. So this is the algorithm what I told. So calculate the mid. If it is equal, right, then you return it, right? If it is less than, then you do the right equal to mid minus like yeah, mid minus 1, or else is greater than, then left equal to mid plus 1. That's all we need to do. But the question is, you are doing a loop here, right? So how you are doing loop? So but till what time? Try to understand, I'll explain. So there will be while loop. So while left is less than right, right? So I need to continue till what, right? So left is here, right is here. I'm changing left, right, left, right. So till that point, left is less than only right or equal to, so less than right, right? So then only I will complete, right? I'll keep on doing. Or else, if sometimes left is going to be greater than right, so then I will just immediately break it, right? Otherwise it is going to be infinite loop, right? So till which point left is less than right, in this point, right? So that way, right? So we'll be just 1 second. There is some issue seems. Just 1 second. Okay, fine. So let's continue. Okay, so so till what point we'll go? While left is less than right, right? So what we'll do? So every time I need to calculate the mid, right? So mid is what? Left plus right divided by 2, right? So that is what my mid, right? And once I find the mid, I will try to compare this mid with this data. If they are equal, then return. If they are not equal, so this is the three case I need to write actually, right? So what is the first case? First case is that is check if they are equal, right? If ARR of, so whatever the mid you got, right? So ARR of mid equal to data, right? Mid equal to data, then you can return, right? Immediately you can return. Returning what, right? Returning the index is mid, right? Returning the mid, right? So this is what you need to return. Then or else, right? Else if, right? If ARR of mid is less than data, right? You can take less than or greater than, whatever condition you can take, right? Less than data, right? So what will happen? Then what will happen, right? If it is this case, so left is mid plus 1, so this is right is equal to mid minus 1, right? So right is mid minus 1, else left is mid plus 1, right? So I will explain one more time. So Okay, so this is the all logic, right? So basically, so what we are doing, so until unless the left is less than right, so till that point, so what you are doing, you are calculating the mid, and if it is you are getting a match, if you are getting a match, then return immediately, return that mid. This index, mid means that index, try to understand. Okay, if it is less than, so if it is less than, right, so the data is less than, right, or else if it is the data is greater than, right, so if it is if the data is greater than, right, so if the data is greater than here, then what you will do, so you will just change your right. So yeah, so this is greater, right, so your data is greater, right, so you will change your right. If data is greater, right, so then what you will do, so you will just do is left equal to mid plus 1, right. So that's what you will do, right. So right is I think this will be your data is, yeah, data is ARR, data is greater than, right, so ARR of mid, ARR mid is this, so this one is greater than the data. Okay, so that means, yeah, so you are searching for less element, so this will be greater than. Okay, so that means here there is a bigger number is there, right, so here there is a bigger number, right. So if suppose you are searching for 20, so here there is a bigger number, so this is your mid, right, and here there is a bigger number, so then your right, so your right is going to change to here, right, right is going, because your search space is going to be here. Okay, so that will be greater than data. Okay, or finally you will return, right, so finally you will return -1. If there is nothing like that, so you will return -1, and it will be outside the while loop. Okay, so this is all about the binary search. Okay, so this is the all about the binary search. Any